Hi everyone, in this video I'm going to be going over how we use quadratics in real life scenarios. So in class we did an example about baseball, but this example is going to be about basketball. It's pretty much the same idea, we just have a different type of ball being thrown into the air. So this graph represents the height of a basketball, h, in feet as a function of time, t, in seconds after it was thrown from a platform. So again, we have the units feet for height and then the unit seconds for time. And the equation we're given is h of t equals negative 16t squared plus 57t plus 9. So the first question asks, what is the initial height of the basketball? Now, a lot of you might want to look at the graph and look at the y-intercept, so where the red curve is crossing the y-axis. And when you look at the graph, you might think the answer is 10, but it's not quite 10. This is why it's actually better for us to look at the equation. So if we're looking at the equation, the way we can always find the initial height or the y-intercept is by looking at the c value, which is the number by itself at the end of the equation. So in this case, that is 9 feet. Okay, so again, you can look at the graph, but sometimes it's kind of hard to tell. It's a close call. So that's why it's always better to get the more accurate answer by looking at the equation. Look at the c value. That's the constant by itself at the end of the equation, and that is 9. And then don't forget your units. We're talking about height in feet, so the answer is 9 feet. Next, we are asked, what is the initial speed of the basketball? We learned in class that we can look at the middle term, the linear term, to figure out the initial speed. So we can look at the number next to t in the middle of the equation, that's 57. Okay, and we said that the 57 tells us our initial speed is 57 feet per second. So to find our initial speed of whatever's being thrown into the air, in this case it's a basketball, that is, we look at the linear term in the middle, the number with t tells us the initial speed of the basketball, 57 feet per second, not miles per hour, feet per second, because those are our units for this problem. And then what does the term negative 16t squared represent? Now, I always remember that since this is the only negative term in my equation, this must represent the force that is pulling the ball down to the ground, and that force is gravity. Okay, so I always remember my only negative term, that's representing gravity. It's pulling the ball down to the ground. That plus 57t, it's positive, so it's representing the ball being launched into the air at an initial speed of 57 feet per second. And then the plus 9 just reminds us that the ball is starting 9 feet above the ground initially. Okay. Now, the one other thing we learned that we can figure out from the graph or the equation is after how many seconds does the ball hit the ground? So first we're going to estimate by looking at the graph, and then we're going to use the quadratic formula to find an exact answer. So if I'm trying to figure out after how many seconds does the ball hit the ground, then I need to be looking at where my red graph touches the x-axis. So I can see that there's 2 spots where it touches the x-axis, but one of the spots is to the left of 0. That's a negative time, so that doesn't really make sense, so I'm not even going to look there. I want to look over at the right side where the red graph touches the x-axis, and I can see it's between 3 and 4. It's a little closer to 4. If we break it down between the 3 and the 4, it's going to be at around 3.75. Okay, if you said 3.5 or 3.6, that would be close to. You do want to make sure you pick a number that is closer to 4 than 3. So 3.5 is okay, but not the best estimate, because we can tell it's definitely closer to the 4. So our estimate is that it takes about 3.75 seconds for the ball to hit the ground. But of course, we want to know how to get a more accurate answer, an exact answer, by using the quadratic formula. So the reason we're going to use quadratic formula is because our x-intercept always occurs when y is equal to 0. So it's like if I take my equation from the last slide, but I replace the height on the left side with 0, I need to solve this and figure out at what time is the height 0. So in other words, at what time does the ball hit the ground? Okay, and it's a quadratic equation, and we know we can always use quadratic formula to solve a quadratic equation. We could use factoring, but I don't think this would be very easy to factor. So we're not going to use factoring, we're going to use quadratic formula. And my first step is to identify a, b, and c. A is the number in front of t squared, so negative 16. B is the number in front of t, so 57. and C is the number by itself at the end, so 9, okay? And then I'm going to use my quadratic formula shell, okay? When you're doing your practice, you do have to write the shell on your own. I have the quadratic formula here in the top right corner, so you just need to replace any of the variables with empty parentheses so that then we can plug in our A, B, and C values. So my first set of parentheses, my formula says negative B, so B goes in the first parentheses, that's 57. Then it says plus or minus square root of B squared, so that means 57 goes in the next parentheses as well, minus 4AC, that's what our formula says, so minus 4, A goes in the next parentheses, that's negative 16, C goes in the next one, that's 9. All divided by 2A, so that means negative 16 goes in my parentheses there. So I just figure that out by looking over at the formula. Okay, now I'm going to simplify it into 3 parts. Okay, first the part in front of my plus or minus sign, I have a negative and a 57, so negative 57. Under my square root, I have parentheses 57 squared minus 4, parentheses negative 16, parentheses 9. I have to use a calculator for this. This would be really hard to do without a calculator. So let's look back. We got to remember what to type in. So I'm going to type it in exactly as I see. Parentheses 57 squared minus, actually I think I can split my screen. Yeah. So there, we're going to type in exactly what we see. Oh no, didn't mean to do that. Okay, I'm trying to find my, oh, there's my parentheses. 57 parentheses squared minus, you can't forget any of the parentheses, 4 parentheses negative 16 parentheses, parentheses again, 9. So I literally just copied that exactly as I saw it. So I get 3,825. That's a pretty crazy number. I'm going to keep the calculator up because we're about to use it again. Okay. And then in my denominator, I have 2 parentheses negative 16. That's 2 times negative 16. If you don't know what that is, of course, you can put it in the calculator. You get negative 32. All right. My last step is I am going to get 2. I always get 2 answers. Now, normally we just leave everything in the quadratic formula, but we're going to take it a step further because we've gotten pretty good at quadratic formula. So we can take this a step further and actually put this in the calculator to get 2 answers. Plus, I can't tell how many seconds it is by looking at this. I need to actually get like a number, a decimal. So the way we do this in the calculator, we're just going to type exactly what we see, except we're going to type it once with the plus sign and once with the minus sign. So first I'm going to type the negative 57. It says plus or minus. I'm going to do the plus first. You could do the minus first. I always do the plus first. So I just put a plus sign and then square root 3,825. Now we're not done. I have to divide all of this by negative 32. So the way I do that, there's a couple different ways you could do it. Sometimes I highlight it. It's kind of hard for me to do on here. And then I click the divide sign, or you can just put, oh, that's not what I meant. You can put parentheses. You can just click the parentheses button and it puts all that into parentheses and then click the divide sign. If you don't put the parentheses first and you click divide, then it won't divide all of it. So that's why I put the parentheses around that and then click divide so that it divides the whole thing by negative 32. Now I know that seems a little tricky, but the good news is once we do it one time, all we have to do is switch the plus to a minus to get our second answer. So our first answer, it says it's negative 0.151 seconds. And then to get my second answer, I just have to do the same thing, but with a minus sign. I don't even need to type this all again. I can just change that plus to a minus, and I get 3.714. So obviously, one of these answers doesn't make sense, right? The negative doesn't make sense. I'm going to make this bigger again. The negative answer doesn't make sense. I'm not going to have a negative time. The positive answer makes sense, and it makes sense because we did estimate 3.75. So I shouldn't be surprised that my answer is about 3.7. So that also helps us to know that our answer is correct just because it is close to our estimate. So the accurate, most exact answer for how long it takes for the ball to hit the ground is 3.714 seconds. All right, and that's what you do have to do on the second homework problem. You do have to find an exact answer, but estimating always helps. Okay. All right, Good luck with your homework.